Dear student, in this video lecture, we will discuss about Internet Protocol version 4 of delivery mechanism used by the TCP/IP protocol. So, in this topic, contain following section: datagram, fragmentation, checksum, and options. These type of header are included in Internet Protocol version 4. So, the TCP/IP datagram format shown here. The TCP/IP protocol format contain 4 layers. First is the application layer, which is contain the several type of protocol like SMTP, FTP, TFTP, DNS, SNM, and BOOTP. Next is the layer of TCP/IP protocol is transport protocol layer. It contains following the protocol as stream control transmission protocol, transmission control protocol, and user datagram protocol. Network layer, which is contain IPv4, and next combined layer is physical layer, which is underlying the LAN and WAN technologies. So IPv4 datagram format like that. The total IPv4 address is 32-bit. It contain mainly data in form of header and data. Header like that 20 to 60 bytes, and the size of header and data equal to 20 to 66 and 1536 bytes. So following segment of datagram format, first field is content version, which is contain the 4-bit. Next is header length, which contain the 4-bit. Next field of the IP datagram pool, service, which contain 8-bit, and next total length equal to 16 bits. Now 16-bit used for identification, and 3-bit used for flag, and 13-bit used for fragmentation offset. Now 8-bit used for time to live, and 8-bit used for protocol, and 16-bit used for header checksum. Now source IP address is contained 32-bit, and destination IP address is contained also 32-bit. And option field used for future result. So this is the IPv4 datagram format. Now precedence of subfield was part of version 4 but never used. So type of service means if type of service bit written like that 000 normal and default, 001 means minimize cost, 001 maximize reliability, 0100 maximize throughput, and 100 means minimize delay. This bit are represent type of service, या TOS bits. Similarly, default type service for ICMP, TOC bit represent 000 for normal, BOOTP also TOS represented by 4 times 0 normal, NNTP, IGAP, and several type of protocol. Their time of service bit here and their description are shown in this table. The total length field define the total length of the datagram including the header. So data less than 46 bytes, length of minimum 46 bytes. L2 is the portion of header, some padding length, and trailer used for the extra bit for redundancy mechanism. Next protocol field encapsulated with several type of protocol like transport layer, SCTP, TCP, UDP, and network layer. Header contain ICMP, Internet Control Message Protocol, Internet Group Message Protocol, and Open System Protocol. The value of the protocol field define which protocol the data belongs to. So ICMP value is denoted by 1, IGMP value denoted by 2, TCP denoted by 6, and UDP denoted by 17, and OSPF denoted by 89. For example, an IPv4 packet has arrived with the first 8-bit as shown. Receiver discard the packet. Why? The main solution of this example, there is an error in this packet because the 4 leftmost bit 0100 show the version which is correct. The next 4 bit 0010 show the invalid header length because 2 into 4 equal to 8. The minimum number of byte in the header must be 20. The packet has been corrupted in the transmission. Next example. In an IPv4 packet, the value header length equal to 1000 in binary. How many bytes of options are being carried by this packet? The solution of this example, the header length value is 8, which means the total number of bytes in the header is 8 into 4, means 32 bytes. The first 20 bytes are the base header, so next 12 bytes are used for the options. Similarly, in an IPv4 packet, the value of header length is 5 and the value of the total length field is 0x0028. How many bytes of data are being carried by this packet? The solution of this example, the header length value is 5, which means the total number of bytes in the header is 5 into 4 or 20 bytes, no options. The total length is 40 bytes, which means the packet is carrying 20 bytes of data and 42 20. So maximum transfer unit MTU means IP datagram header and MTU maximum length of data to be encapsulated in the frame like that. Now, show the figure. So an example of checksum calculation for the IPv4 header without option. The header is divided into 16 bit section. All sections are added and the sum is complemented. The result is inverted in the checksum field. For example, checksum is this field are denoted by checksum. If 4, 5 and 0, that is represent 0, 28 represented by this, 1 represented by this, 0, 0 represented by this, 4, 17 represented of this, and this is the total sum of these 7 to 9, total sum of this. After sum, we find the checksum value 8BB1. This is the value of checksum. Simple. We calculate 4500 001C for 28 representation of 28 for representation of 0001 representation of 0 equal to 4 times 0 4 to 17 representation of 4 equal to 411 and representation of 0 000 10 12 this 14 5 this 12 6 this and 7 9 this. After the sum of these fields, we find 744E and using the complement, we find the checksum 8BB1 and this field is denoted here as a form of checksum. So despite all short-term solution, address depletions is the still long-term problem for the internet. This and other problem in IP protocol itself has been the motivation for IPv4. So next version of IP addressing like IPv6 is the extension of IPv4. IPv6 address is 128-bit long and IPv6 address is binary and hexadecimal colon notation like that. 128-bit means 16 byte equal to 32 hexadecimal digits represented like this 111 dash and these addresses are represented in 4 next segments like that FDC this 8 segments of 4. Now IPv4 original address represented like this, abbreviated of this and more abbreviated like that. Gap is represented by this double colon. Expands the address 0, 50, 112, 1213 to its original. We first need to design the left side of the double column, left of the original pattern. and right side of the double colon to the right of the original pattern. To find how many zeros, we need to replace the double colon. First 0, 15, 1, 0, 15, 1, 12, colon, 12, 30. This means that original address is 0, 0, 0, 0, 15, 4 times 0, 4 times 0, 4 times 0, 0, 0, 1, 0, 0, 1, 2, and 12, 13. So multicast of IPv6 represent like the 8-bit flag, scope, group identification 1 to 12 bits. Flag is per moment 0, 0, 0, yeah, 0, 0, 1. Scope 4 times 0 for reserved, 0, 0, 1 for node local, 0, 1, 0 for link local, and 0, 1, 0 site local, 1, 0, 0 organizational, 110 global, and 111 means reserved. So reserved address IPv6 showing that here in diagram 8-bit 0, all of zeros unspecified, 8-bit 0 and 120-bit 0, 0 to 1 loop back, 88-bit all zeros, 32-bit IPv4 compatible, all 72 bits all zeros, 16-bit all ones, 32-bit IPv4 mapped, link local and site local. So IPv6, the network layer protocol in the TCP IP protocol. So it is currently IPv4, although IPv4 is well designed. So data communication has evolved since the inception of IPv4 in the 1970s. IPv4 has some deficiencies that make it unsuitable for the fast growing internet. So represented here the IPv6 datagram, header and payload. The IPv6 data base header length equal to 40 bytes and payload equal to 65535 bytes. So extension of header is optional and data packet from upper layer. The format of IP6 datagram showing here 4-bit used for version, priority bit used for 4-bit, and flow level needed 24-bit. Payload length, next header, hope limit. Now source address, destination, and this next header work as an input of next header length, and this process, a continuous process in the IPv6. The next header code for IPv6, 0 denoted by hope portion, 2 ICMP, 6 TCP, 17 UDP, 43 source routing, 44 fragmentation, 50 encrypted security payload, authentication, null and destination option 16. Priorities of congestion and control traffic means for priority 0 means no specific traffic, 1 background data, 2 unattended data traffic, 3 reserved, 4 attended bulk data traffic, 5 reserved, 6 interactive traffic, and 7 control traffic. This is the priorities for the congestion control traffic. So some basic difference between IPv4 IPv6 packet like that. The header length field is eliminated in IPv6 because the length of the header is fixed in the version. The service type field is eliminated in IPv6. The priority and flow level field together take over the function of the service type field. And third difference, the total length field is eliminated in IPv6 and replaced by the payload length fields. The identification flag and offset field are eliminated from the base headers in IPv6. They are included in the fragmentation extension header. Now next difference, the time to live field is called hop limit in IPv6. The protocol field is replaced by the next header field. The header checksum is eliminated because the checksum is provided by upper layer protocol. It is therefore not needed at this level. The option field in IPv6 are implemented at extension header in IPv6. That is the basic difference between IPv6 and IPv4. Extension of header type like that hop to hop, source routing, fragmentation, authentication, encrypted security payload, and destination option that are extension of header. So this is the basic difference of between IPv6 and IPv4. So IPv6 is more secure with respect to IPv4. IPv6 has more address with respect to IPv4. The address of IPv6 is 128 bit and the address of IPv4 equal to 32. Thank you.